Good morning and welcome to Wednesday of week 2 of your Physics 5 a day, and today we're starting the forces topic. And we're going to start by reminding ourselves that we have two different types of force diagram. The first is a free body diagram, and this is where we represent one object and then we draw only the forces acting on that object. So my example here, I'm imagining this is a tennis ball that's been thrown. So it's moving through the air this way. We've got a weight force downwards and an air resistance force on a diagonal at an angle of 45 degrees. Okay, so that's a free body diagram, one object and the forces acting on that object. The other type of diagram is the diagram that we draw when we want to add forces together. To add these two forces together, I draw one of them first, and then where I finish drawing that arrow, I start drawing the next. So we often describe this as drawing them nose to tail, where one arrow finishes, the next one starts. Okay, but what's the answer? What is this plus this? It starts from where the first arrow starts, and it finishes where the last arrow finishes. So this here is my answer. This force plus this force equals this total force. Now, if I want to work out how big that is and what this angle here is, then I'm going to either have to use the cosine rule or I can draw a scale diagram. So in my diagram, I'm going to represent 1 Newton by 2 centimetres. So here we go. Okay, so here's my 2 Newton force represented by a 4 centimetre arrow. And oops, here's my 3 Newton force represented by a 6 centimetre arrow, and it's all measured accurately, and that includes the angle, so you have to use a protractor to make sure that you've got that angle right. Now, while that might seem like a bit of a faff, now when we draw in our answer vector, remember from the start of the first arrow to the end of the last arrow, now when we draw that in, to find the length of it, all we have to do is measure. So I'm getting, I think I'm going to say that's 9.2 centimetres there, which means it's 4.6 newtons. And instead of having to calculate the angle, I can just measure it with a protractor, and it came out as about 27 degrees. Now, obviously, when you draw a scale diagram, if two people do it, they're not going to get exactly the same answer, but don't worry because the mark scheme takes that into account. So they would have a range of values that would be acceptable for the angle and the length. So now here's an example. Okay, so I have drawn a great big, it doesn't even fit into the screen there, a great big scale diagram. And remember that the answer is from the start of the first arrow to the end of the last arrow. And measuring this answer, I got 3.5 centimetres, so converting back to newtons, and with the protractor measuring that angle there. Now don't forget, the question didn't ask us for the angle to the vertical. It asked us for the angle to the horizontal, so don't forget to put that in. But you may have noticed that there was a shortcut here. It's very easy in your head to do 120 up and plus 90 down. It's going to get 30 up. So you're totally okay to shortcut there and just add together the 30 upwards and the 18 to the right. This, however, is a bit small for a scale diagram. So if you had done this with a scale diagram and the shortcut, I'd have suggested 1 centimetre to maybe 5 newtons instead of the 1 centimetre to 10 newtons that I've got there, because that's just a little bit small.